As many can attest, when you join the Censored Earth community, you are given a new set of eyes. Now, I've studied Earth science before, but now that I've been given a new set of eyes, I'm going to go back and take another look and tell you what I see. This is modern Earth science destroyed. Introducing Earth science.
Studying the Earth is like putting together a complex jigsaw puzzle that is made up of pieces that are constantly changing shape. As time passes, many of the pieces change so much that they don't even resemble their original shape. Or worse yet, some of the pieces are even destroyed or replaced with different pieces. The only constant in this puzzle is change. Does this description surprise you? Perhaps you think of the Earth as being constant and unchanging. After all, the Earth is made up of some very durable materials, such as rock. Compared to most things, rock does not seem to change much. Appearances, however, can be deceiving. The Earth, in fact, undergoes incredible changes. It's just that many of these changes happen very, very slowly. So, what do you think about all that?
Well, the Earth certainly does go through a great amount of change. So I agree with them about that. But the principles and concepts involved in how the world works are the things that don't change. That is my opinion anyway, and I openly acknowledge it as such.
So are your opinions the things that destroy what is written in this book?
No. Let's continue on and you'll see what I mean.
Alright, let's keep reading. Of course, not everything on Earth occurs slowly. Earthquakes, tornadoes, tidal waves, and lightning strikes, for example, occur so quickly they pose their own sets of problems for Earth scientists. Imagine the task of studying a phenomenon that occurs randomly at an unknown location and only lasts for 30 seconds. That's exactly what Earth scientists face when they study earthquakes. Seem impossible? It is difficult, but not impossible. Such studies require creativity and an innovation. This site was a seabed about 200 million years ago. Much has happened here since then. Today it is known as El Capitan of the Guadalupe Mountains.
Whoa! Let's circle that right there. Do you think the authors of this book are 200 million years old?
No, not at all.
They're making a claim here and don't provide any evidence to support their claim. They are saying this is true because they said so. Or they are expressing an opinion and are treating it as though it were a fact.
That is a problem.
Yeah. Science is the systematic knowledge of the physical or material world gained through observation and experimentation, according to dictionary.com. Without observation and experimentation, we can't call that claim science. It is important to notice when the authors make these kinds of claims. Far too much dogma out there is based on opinion rather than fact. And this happens when people choose to just go with the flow and fail to recognize when claims like this are being made. Scientific doctrine should be based on well-founded conclusions rather than flimsy hypotheses. Now, as many might recall, in my Censored Earth series, I previously did a video entitled Cards on the Table. Now let me show you how this works. Herein the authors of the book have laid a card on the table. I just refuted their card and have explained the problems I see with their card. Now if their card was a cake, rather than complaining about the only cake on the table, I am going to provide a better cake and put that on the table. And I am going to try and do this as often as I can throughout this series.
I like that. We're not trying to knock their cake off the table and leave them with nothing. We want to provide people with something better. Can you imagine if everyone did that? It could lead to some pretty amazing cake.
If you feel like you have an even better cake than the one I present, I want to see it and take a bite of it. Please present it on our public debate board. There's a link to that in the description. Alright, so here's my cake. People often judge the age of a mountain by the layers of dirt they see in a mountainside.
Oh yeah, kind of like judging the age of a tree by counting the number of tree rings.
Yeah, but layers of dirt work differently than the rings on a tree. These are the results of a soil test. When you do a soil test, you go out and take different samples of soil from different places in your yard, put them in a jar, pour some water in, and shake it up really well so that it is all suspended in the water. And then you just wait and watch it all settle. After letting it sit, these are the results of one such soil test. Now, does it take millions of years to get the soil to settle in layers like this? No, it doesn't even take a full day to get results like this. I'll also point out that I have rings of sediment on this plastic pitcher, and it didn't take millions of years for these rings to form, nor is this pitcher millions of years old. So do the layers of dirt on a mountainside suggest that the mountain is millions of years old? No. A massive flood could produce results like that in a relatively short amount of time. So here is my cake. It doesn't take millions of years to produce mountains like those. And because I have backed up my claim with observation and experimentation, I can claim that my cake has more flavor. And I can call my claim a scientific one. Again, if you think you have a better cake, don't put it in the comments section. Put it on the debate board where we can study it in depth. If your cake is truly better than mine, I'll happily toss mine in the trash and celebrate yours. Alright, let's continue.
Earth scientists use elaborate systems to pinpoint the location of earthquakes, yet they still do not know enough to predict when and where they will occur. Earth scientists also beat the odds when they study remote locations. Consider the difficulty of exploring the bottom of the ocean at depths of more than 10 kilometers. Or consider the exploration of other planets and outer space. Earth scientists use technology in new and incredible ways to achieve such difficult observation and studies. Meteorologist, geologist, oceanographer, and astronomer are all specialties within the area of Earth science. Together, these scientists attempt to understand our physical home within the universe. Such understanding will help us make wise decisions both now and in the future. Oceanographers often go to great depths and take great risks to add to their understanding of the oceans. Hot situations such as this one on the right are not unusual for an Earth scientist who study volcanoes. Begin your own journey of understanding by turning the page and entering the realm of Earth science. I'm proud to be your guide on what I hope to be a fascinating and enlightening experience. From Robert J. Sagar.
We're going to skip these safety precaution pages, I hope you don't mind. Although this part about explosion danger really gets me wondering what kind of experiments are in this book.
Just don't blow yourself up.
Alright, concept mapping.
What is a concept map? Have you ever tried to tell someone about a book or a chapter you've just read and you find that you can only remember a few isolated words and ideas? Or maybe you've memorized facts for a test, and then weeks later you're not even sure what topic those facts were related to. In both cases, you may have understood the ideas or concepts by themselves, but not in relation to one another. If you could somehow link the ideas together, you would probably understand them better and remember them longer. This is something a concept map can help you do. A concept map is a visual way of choosing how ideas or concepts fit together, and it can help you see the bigger picture.
How to make a concept map. Make a list of main ideas or concepts. It might help to write each concept on its own slip of paper. This will make it easier to rearrange the concepts as many times as you need to before you've made sense of how the concepts are connected. After you've made a few concept maps this way, you can go directly from writing your list to actually making the map. Our debate board makes things really easy for this. Spread out the slips on a sheet of paper and arrange the concepts in order from the most general to the most specific. Put the most general concept at the top and circle it. Ask yourself, how does this concept relate to the remaining concepts? As you see the relationships, arrange the concepts in order from general to specific. Next, connect the related concepts with lines. On each line, write an action word or short phrase that shows how the concepts are related. Look at the concept map on this page and then see if you can make one for the following terms: the solar system, the sun, planets, star, Earth, Jupiter. An answer is provided below, but don't look at it until you try the concept map yourself. Look at that. They're saying the Earth is like Jupiter. It'd be interesting to expand that and do a more detailed comparison between the Earth and Jupiter on the debate board. Alright, so here is our debate board. We try to model our debate board off of a concept map as much as possible. We're going to add each page of the book to the debate board so anyone can highlight anything and make commentary about it. Here I have the first page, and down below in the red boxes, I've attached my 4 counterarguments to their claim about the age of the seabed. My first counterargument is, the authors of the book are not 200 million years old and can't verify the age of the seabed as first-hand witnesses. My second counterargument is, a claim without observation and experimentation to back it up is not a scientific claim. Then down below in the blue box, which is my support box, I've got the quotation for the definition of science, according to dictionary.com. And in that bottom corner, I've got a link to dictionary.com where you can go and see it for yourself. My next counter argument is, all the authors have given us to go on the matter is their word for it. They're saying, we are the experts, therefore you should trust us. This is the genetic fallacy, where someone judges something as either good or bad, or right or wrong, just because of where it came from. Just because someone has a PhD doesn't mean they are infallible and incapable of saying something that is wrong. Nor does that mean that someone without a PhD is incapable of saying something that is right. Now, if you see something you disagree with, just make a box and write your counter argument in the box. We go with red boxes for counter arguments, and then we just take an arrow and point it to the claim that we disagree with. On the debate board, you'll notice that we have already uploaded each of the pages of the next lesson. If you can make some good comments on any of that, we'll be sure to include them in our next lesson. So that is it for the introduction. Please note how we did not disagree with everything that was written, but in fact celebrated the common ground that we were able to establish. That is how we intend on valiantly fighting with honor and love.
As we build bridges of understanding through finding common ground, that is where persuasion can take place, and real victories can be won.
So long as wars are a matter of flesh and blood, nothing ever gets accomplished. The moment your enemy is slain, it is only a matter of time until someone else comes up with the same idea and takes their place. But when successful persuasion occurs, that is when their army becomes your army, and your enemy becomes your friend. That is the kind of victory that we are after.